Hello everyone. In this example, I'm going to look at completing the square of a quadratic formula. Recall, for completing the square we have four main steps to review. For the quadratic formula, ax squared, or the quadratic equation I should say, ax squared plus bx plus c equals 0. To complete the square we want the leading coefficient, our a value, to be positive 1. So let's look at the equation. 9x squared minus 6x minus 4 equals 0. If my first coefficient, my leading coefficient, my 9, is to be 1, the simplest way I can do that is by dividing everything by 9. So now I have x squared. Now 6 over 9 reduces to 2 over 3. X minus 4/9 equals 0. Now my leading coefficient is positive 1. Next I want all my variables on one side. So what that means is I want just the x squared and the x to be on one side of the equation, which means I move my 4/9 by adding it. So now I'll have x squared minus 2/3 x equals positive 4/9. Now looking back to my steps, I want to add the quantity b over 2 squared to both sides. Now for a question like this, it can be tricky because we're working with a fraction. But I want to use b as it is at this point. So in other words, I would not use 6 or negative 6 as the b value. That's what we started with. We do want to use 2/3, or negative 2/3 in this case. So I'm going to take negative 2/3, take half of it, and then square it. So if you look over here, remember b is negative 2/3. Now if I take half of b, that's what this represents, b over 2. Here's my b, negative 2/3 divided by 2. Now if you recall your definition of division, this is equivalent to saying 2/3, my top number, times the reciprocal of the 2. And this works with any fraction. Anytime you have a fraction as b, this is how you evaluate. Now if you're wondering, well, shouldn't it be 2 over 1? That's what it is at this point where I circled. It's actually 2 over 1 right there. We just usually write it as 2. So then the reciprocal of 2 is 1 over 2, and that's where I get it from. So b over 2 is actually 2/6, or in this case, negative 1/3. Or I should say negative 2/6, which is negative 1/3 after I reduce. So again, I got that by dividing negative 2/3 by 2, which turned into multiplication of the reciprocal, leaves me with a negative 1/3. So when I square that quantity, when I square my b over 2, I'm taking negative 1/3 squared, and that will give me a positive 1/9. So I'm going to add 1/9 to each side. At this point, I want to solve. And I can solve by factoring, is what I'm going to do. So I'm going to factor this side. For problems with fractions, we can use the traditional factoring method, or a shortcut that will always work is I can take, or since I added 1/9 each side, what this does is it creates a perfect square trinomial. In other words, it's always going to be in the form x, or whatever the variable is, quantity squared. So by default, before I do any math, it's going to be in that form once I finish factoring, always. It's always quantity squared and then a variable. What we need to figure out then is what goes in there with the x. What do I add or subtract to it? And you can always fall back on whatever your b over 2 was. Not b over 2 squared, not the 1/9, but just the b over 2. In this case, that's a negative 1/3. And put that in its place. And that will always work. Helpful for getting around fractions and avoiding having to do any particularly complex factoring. On my right, 4/9 and 1/9 add up to a positive 5/9. Now to solve, I'll take the square root of each side. So now I'll have, let me go to a new page, I'm running out of room. So I have x minus 1/3 is equal to the square root of 5/9, and I need a plus minus. Make sure I got that. Now I want to break down my fraction to make this square root of 5 over square root of 9, which means I can reduce. This is now x minus 1/3 equals plus or minus square root of 5 over 3. Lastly, I want to solve for x. I will add 1/3 to both sides. So x equals 1/3 plus or minus the square root of 5/3. And here 1/3 will go in front of the plus and minus. And this is my answer. One variation you do have of this is, because my denominators are the same, they both have 3, I can write as a single fraction as such. Either one are valid answers. The one on the right, if you are familiar with using the quadratic formula, it will often give you an answer like that. So this is how we complete the square.